Hello class, it's Mr. Cablan here, and this lesson will be dealing with how we can come up with the equation of a line in the form of y equals mx plus b, looking at the various techniques that we have covered up until this point, as well as other techniques that we can use in order for us to determine the equation of a line. And some of the examples we will be looking at will be dealing with what we can do when we have graphs, which we have been introduced to already, as well as what we can do when we don't have graphs. So let's get right into it. So like I mentioned before, what we're going to do today is actually in the first example, we're just going to quickly go over how we can find the slope of a line using a right triangle, and then finding the y-intercept simply by determining where the line crosses the y-axis. And one of the examples we're also going to look at is that we can also solve for the equation of a line, provided that we have the slope of the line, of course, as well as taking a point on the line and using that and solving for the y. So that's going to be the y-intercept. So that's going to be the new thing we're going to be looking at in this lesson. And don't forget that once we solve for the slope, that replaces the m. So we always do that in the first step. And then after that, we can find or solve for the y-intercept, which is the letter b. So you're going to see in all the examples we're going to see for today, we will be following the same set of steps. The only difference in each case is that as we go through this lesson here, the number of steps and the number of detailed steps will be trickier as we go along. But like I said, ultimately the main steps that we're going to use in order to solve for the equation of a line will be exactly the same. So let's take a look at an example similar to the ones we've seen up until this point. So as you can see, we have a line that's going up to the right, and we have two little tiny points there to help us find the slope of this line. So what we're going to do here is we're going to use just the graph to calculate the slope of the line, find where it crosses the y-axis, and then from there come up with the actual equation of the line here. So again, remember that all equations of the lines are given in the form of y equals mx plus b. And the very first step that we're going to do here is to calculate the slope. And since we have graph here, we're just going to use a right triangle using the formula rise over run. So you can see that we're going to connect those 2 points that you see on the screen there. And then from here, we're just going to count the rise and the run. So the rise, again, as you can see, is the distance from the 1 point and to the edge of the right triangle there. So the rise here will be 1. And the run here is the distance going from left to right, from the bottom left point to the corner of the triangle, and that's going to be 4. So what we have here is a rise over run of 1 over 4, which is already going to be a fraction in lowest terms. So the next thing we're going to do here, we're going to take a look at the line and see where it touches the y-axis. Okay, and you can see here this line touches the y-axis here at 2. So that's going to be our b value. So just double check, we now have our slope, which is going to be our m, and our slope here is going to be 1 over 4, and that's going to go for the letter m. And our y-intercept here is going to be the b, which is 2, and that's going to replace the b. So for the grand finale here, we're just going to replace those numbers in for their letters accordingly. So the equation of that line there will be y equals 1 over 4x plus 2. Okay, so this particular example, again, is exactly the same as the ones we've seen, but I just want to introduce the topic just to show you that the 3 steps that we're going to look at will be exactly the same for all examples we're going to see for today, again, with the level of difficulty increasing as we go along. So we're just going to do the same thing for the next example here. So this time here, we have a line that is falling down to the right. So just remember that any line falling down to the right is going to be a negative slope. Okay, so same set of steps. So our first step here, we're going to calculate the slope using rise over run. And in this case here, just to show you that we can also create a right triangle above a line, I'm going to do that for this example. So you notice those 2 points that I've connected there. I'm just going to draw a right triangle above it like so. Okay, so remember this is a negative slope. So when we do the calculation, don't forget to put the negative symbol here. So for the rise here, starting from the point on the bottom, and we'll count the number of boxes. So you notice we have the 4 boxes for the rise, and the run here will be 2. So right now we have a slope here of negative 4 over 2, and this reduces to negative 2. Okay, so that's our very first calculation for this line. So the next thing here, we're now going to see where the line touches the y-axis. So you can see here the line touches the y-axis here at 5. Okay, so double check, we have a slope and we have a y-intercept. So for the last step, we're just going to come up come up with the equation for that line. So all we're going to do here is replace the -2 for the m and the 5 here for the b. So the equation of that particular line there will be y equals -2x plus 5. All right, so you can see here that everything we've done so far is nothing new. So in the next two examples here, we're now going to look at something new here. So what you notice already for this next example, we only have that piece of information and we don't have a graph. But you're going to see that as long as you follow the same 3 steps that we have been doing, okay, the approach to this question is exactly the same here with one slight difference. So it says here, a line of slope of 3 passes through the point 5, 13. And it says determine the equation of the line in the form of y equals mx plus b. So all we're going to do here is we're going to take that first paragraph there and just replace that information there into the equation y equals mx plus b. So step number 1, as you can see, you guessed it, we're going to determine the slope and then we're going to substitute it into the equation. Okay, so again, always start off by writing the equation. Remember that all lines are given in the form of y equals mx plus b. And in this case here, the slope is given to us, and it tells us here the slope here is 3. So the first step we're going to do here is we're going to replace m with a 3. So we have something that looks like this, y equals 3x plus b. Now, notice all I've done here is replaced the letter m with a 3. Now, what we want to do for this, since we don't have a graph, we now need to solve for the letter b here, and that's going to be step number 2. So it says use the given point, and then from here we're going to solve for the b. So the way we do that is we're going to use the equation from the previous step, which is y equals 3x plus b, and we're going to substitute the 5 and the 13 for the x and the y. Okay, so remember, anytime you see a point, it's always going to be x and y. So the 5 here, that's going to replace the x, and the 13, that's going to replace the y. So when we do that, the x here is going to be replaced with the 5 in brackets, and then 13 replaces the y. And you can see here in this step here, we now only have one letter remaining, which is, well, the b. So in the next step here, we're just going to simplify. So the next thing I'm going to do here is 3 times 5, which is 15. And for the last step here, we're going to isolate the b. So you notice the b and the 15 are separated by a plus sign in this case. So for the last step, I'm just going to take the 15, and I'm going to move it to the other side and subtract it from the 13. So that's going to give me 13 minus 15, which gives me b is equal to -2. Okay, so we have an equation that already has a slope, and now we have the y-intercept. So for the grand finale for this one, we're just going to put it into the equation y equals 3x plus b. And all we're going to do in this case here, because we already put the slope in for the m in the first step, so that -2 is going to go in for the b. Okay, and don't forget to clean this up. Anytime you have a positive and a negative together, just change that to a minus sign. And the final equation for this will be y equals 3x minus 2. So you notice that we were able to come up with the equational line even if we didn't have a graph. Okay, so as long as you follow these first 3 steps, or these 3 steps that you see there, notice again we did the exact same things. The only difference again is that in this case here we didn't have graph. We just used the information in the word problem in order for us to solve for this problem. All right, so again we're going to do the same thing here. So now we're now going to again come up with the equational line. This time we're going to be looking at 2 points on a line, and we're going to start off one with a graph here just as a demonstration. So in this question over here, notice that what we have here is a line that's falling down to the right. So our slope here is going to be negative. Okay, now like I said, we're going to approach this in a different fashion here just to show you that when you have 2 points, okay, and to get you used to actually solving for the letter b, okay, I want you to see how we're going to approach this problem using what we have on the screen there. Okay, so again, we're going to calculate the slope using rise over run. Keep in mind that what we have here is a negative slope. So again, drawing a right triangle, let's start off with the rise. So starting off from the top left point, and we're going to count the number of boxes to the corner of the triangle. So that's going to be a rise of 2. Okay, and what we have for the run here will be a run of 8. So remember, this is a negative slope, so we have negative 2 over 8. And if you do reduce the fraction there using your fraction key, so if you press negative 2, fraction key 8, that's going to give you a fraction there of negative 1 over 4. So we have the slope. Now, for the y-intercept over here, we're actually going to solve for it. But before we do that, don't forget that once you figure out what the slope is, replace the slope in for the m. So we have this formula here, or this equation. Now, if you take a look at this graph over here, you notice that our y-intercept here is 6. Okay, so if you have a graph and you have the y-intercept, okay, just look at where it touches the y-axis, and that will be your y-intercept. But just to show you, and this is the reason why I did this example the way I've done it, it's the fact we are going to solve for the y-intercept, just to show you that when you're solving for it, you do get the y-intercept that's in the graph that you see here. Okay, so that's step number 2. So we're going to take any one of the 2 points you see in the line and then replace it in for x and y. And then, like I said, we're going to solve for the b. So I just randomly picked 4, 5 here just because it's the first point. So if you pick 12, 3, you'd still get the same answer. Okay, again, in this step here, you can pick any of those 2 points on the line and it'll give you the same answer. So step number 1 is going to rewrite the equation here, okay, from the previous step. Now remember that all we're doing here is replacing the 4 and the 5 for the x and the y here. So the 4 is going to go in for the x, and the 5 is going to go in for the y. So in the next step, I'm going to replace the x there with a 4 in brackets, and the y with a 5. Now this is where your fraction key comes in handy here. So if you take a look at the middle part of the equation there, if you punch in -1, fraction key 4, and put the 4 in brackets there, and you press equals, guess what? You don't even have any fractions anymore. Changes into a -1. So again, when you have the fraction key, notice your calculator will do all the steps for you without you having to worry about the fractions there. And for the final step for this one, we're going to take the -1. Okay, since we want to isolate the b, we're going to take the -1, move it to the other side, and then add it to the 5 that's already there. Just remember that when you're moving numbers to the other side of the equal sign, always write it after the number that's already there. And then 5 plus 1 will give me 6. All right. So that's pretty much all the math behind this problem here. So for the final step here, we just need to come up with the equation. So all we're going to do here is take that 6, okay, replace it in for the b, because we already had our m from the first step. So the equation of that line there will be y equals -1 over 4x plus 6. So you can see if you take a look at the top left-hand corner there, okay, you notice that on the top left-hand corner, what you have there of the graph that is, notice it crosses the y-axis at 6. And just to show you that we solve for it, that it does give you that number there. All right, so the next example we're going to see, and this is really, really brand new for you, is the fact that we no longer have a graph in order for us to come up with the equational line. So we have some learning to do for this one. And we don't have a graph, and believe it or not, we only have a word problem to help us solve this problem here. So if you take a look at the title, it says determine the equation of a line given 2 points of a line, and the graph is not given. So the way we do this here, we're going to do the exact same 3 steps. We're still going to find the slope, find the y-intercept, and come up with the equation. The only difference is that we actually now have to solve for both the slope and the y-intercept, okay, using some algebra here. So to find the equation over here, again, we're going to find the slope by using this fancy formula. And you may or may have not seen it, depending what course you took in grade 9. Okay, you also see it in grade 9 science as well. And this is the form that you use to calculate the slope for any 2 points on a line, especially when you don't have a graph. Okay, so this formula comes in really, really handy. So we're going to use that formula, and I will show you exactly how to do it. Okay, and then from there, we're going to solve for the y-intercept by replacing and substituting one of the 2 given points into the equation, and then solving for the b. And then, as I said before, the third step, okay, put it into the equation. All right, so we're going to follow those 3 steps. Again, notice it's the same 3 steps: finding the slope, finding the y-intercept, equation of a line. Same steps, only difference again is the level of difficulty and the number of detailed steps for this one. So for question A here is to determine the equation of a line that passes through the points 3, 7, and 5, 11. So you can see what we're going to do here is we're going to go through each of these steps step by step, so you can see exactly how to use this new formula that I've introduced to you on the left side there. So we're going to use a formula, okay, the y2 minus y1 over x2 minus x1 formula. Now, this next little tiny step is very, very important because it's going to help you understand where these numbers go into that formula. So for the first point, the 3 and 7, we're going to label that as x1 and y1, okay? Now, we always label points as x and y, okay? So that we've been doing that. The reason why we call it x1, y1 is simply because that's the first point. So if that's x1, y1, the second point is going to be x2 and y2. Now, when you're labeling the points, whatever you do, okay, do not mix and match the x's and y's. So for example, don't put down x1, x2, or x1, y2, or any kind of combination here. Just make sure you stick to x1, y1 and x2, y2. You always label the first and second points with those variables respectively. Now, the reason why we do that in the first step here is because we're going to carefully replace the letters in the formula with the numbers that we've labeled. So if you take a look at the top there, notice what we have. There's y2 minus y1. So if you take a look at y2, that's going to be the 11. And then the y1 there is going to be 7. So the top part will be 11 minus 7. And the x2 minus x1, that's going to be 5 minus 3. Okay, so all we've done here is replaced those variables with the things we've labeled in the first step there. And then we're just going to simplify. So 11 minus 7, that's going to give me 4. 5 minus 3, which is 2. And then 4 over 2, that's going to reduce to 2. Okay, so you notice that even though we've done more steps in this particular step, this again is the same thing that we've been doing, which is finding the slope. Now that we found the slope, we're just going to take it at m equals 2, and then we're going to put it into the equation y equals mx plus b. Okay, so that 2 for the m is going to replace that m in y equals mx plus b. So that's our very first step there. Okay, now as part of the second step, like I said, we're going to now solve for the y-intercept. And you can see in the instructions here, it says substitute this slope, which we've done, and one of the points into y equals mx plus b to solve for the b. And I'm just randomly picking the first point here, simply because it's the first point. Now you notice that we labeled it in the first step here, and it makes things a lot easier because you can see here that the x here is going to be the 3, and the y here is going to be the 7. So all we're going to do here is, like I mentioned, the 3 is going to go in for the x, and the 7 here is going to go in for the y. Now keep in mind, you can also use 5 and 11, and it will give you the same answer as well. Okay, so I just picked the first one because it's there. Okay, so the next part here, we're going to replace the x with the 3 in brackets and the 7 with the y, and then we're just going to solve for the b. So 2 times 3, we're going to do that first, which gives me 6. And last but not least here, we're going to isolate the b by taking the 6, moving it to the other side, and then subtracting it from the 7 that's already there. So 7 minus 6, that's going to give me 1. All right, so for the math, we're pretty much done here. So for the final step, this is write the equation by substituting m and b into y equals mx plus b. So since we already have the m from the first step, all we're really doing here is replacing the b here with a 1. So the equation of the line for a line that goes through the points 3, 7, and 5, 11 is going to be y equals 2x plus 1. So you notice you can still come up with the equation of a line even though you don't have a graph to work with. And again, as long as you correctly use the formula in the first step as well as follow the steps, okay, it's the exact same thing anytime you see any 2 points. Okay, so let's take a look at another example here. Same thing. I just threw a couple of negatives in here only because I want you just to just make a note of a little tiny thing you need to be very careful with when you are dealing with negative numbers. So step number 1, we're going to use our brand new formula here. So remember that the first point you're always going to label as x1, y1. And the second point is always x2, y2. And again, just as a reminder, do not mix and match the x's and y's with each other. Okay, keep it nice and simple. First point is x1, y1. Second point is x2, y2. Now, the part I want you to be careful with is actually going to be for the bottom part here. So starting off with y2 minus y1, we have 11 minus 5. However, it's the bottom part I want you to pay attention to. Notice here, x2 here is negative 3. And then you're subtracting the x1, which is negative 1. So if you take a look at the bottom part here, okay, notice what we have here is negative 3 minus negative 1. Okay, it's very important that you see that when you're putting the numbers in for the variables, okay, that you're doing it carefully, especially for the bottom part for this one, because you can see on the bottom, anytime that you have signs that are beside each other, you always have to change it to the proper integer. So if you take a look at the bottom here, you notice what we have here are two negatives. So anytime you have two negatives, you always have to change that to a positive, which then makes this an addition problem for the bottom part. So in the next step, 11 minus 5, that gives me 6. And on the bottom, what I have there is negative 3 plus 1. And then negative 3 plus 1, when you simplify it, that's going to give me negative 2. Okay, so just be careful with that little tiny step there. All right, and then remember that all slopes must be fractions in lowest terms. But in this case, when we go 6 over negative 2, that's just going to reduce itself to a whole number of negative 3. Okay, so that, again, just be careful of that little tiny step there when you're subtracting a negative. So for the next step, we now have our m, so we're just going to replace it into the equation y equals mx plus b here. So the negative 3 is going to replace the m, so we have y equals negative 3x plus b. Okay, so now that we have the m, our next step here is to solve for the b here. So again, you pick any of the 2 points, and again, I just stick the first one, simply because it's the first one, it's the first point that I see. Okay, and we've already labeled that as our x1 and y1 here. So when we put it into this next step, those two numbers will just be the x and the y respectively. So the negative 1 here, that's going to go in for the x. The 5 here, that's going to go in for the y. And when we do that, when we replace the negative 1 in for the x, don't forget to put brackets around it. And then in the next step here, we have negative 3 and in brackets negative 1, which gives us positive 3 when we multiply them together. And last but not least, okay, the 3 and the b are separated by a plus sign. So we're going to leave the b where it is. So we're going to move the 3 to the other side and subtract it from the 5. And then 5 minus 3 will give me 2. Okay, so just double check here. We now have our m, which we already put into the equation, and we now have our b. So for the grand finale here, we're now just going to take that 2 and then replace it in for the b. So the equation of this particular line here is going to be y equals negative 3x plus 2. Okay, so again, notice that for the last two examples that we've seen, okay, the steps that we have followed are exactly the same as what we've been doing when we're coming up with the equation of the line. Only difference, again, as you can see, there's a lot of math involved when we're looking at questions that no longer have a graph. All right, so that wraps up this lesson here. So continue on working in the workbook or in the textbook, and I will see you in the next lesson.